My dear students, today we are going to see a certain topic from the subject called engineering mechanics. So before starting the particular session, let me give a brief introduction about this subject called engineering mechanics. In general, the mechanical engineering stream has three different domains: design, thermal and manufacturing. So this is a very basic subject in design. Next to this engineering graphics, now we are going to study about this engineering mechanics. So this is the fundamental subject for designing of a machine element. What is meant by designing of a machine element? It is the process of identifying the suitable dimensions, required dimensions, and then the suitable materials. Identification of suitable material and dimensions is the engineering designing of machine elements. So to identify the suitable dimension or the required parameters, first of all we need to know the forces acting on the machine member. What is the amount of total load acting on the member? And then what type of load is acting on the member? That we need to identify. That is done in engineering mechanics. Then next to do the force calculations, we need to study about the stresses. What is meant by stress? The resistance force offered by the body against deformation is stress. Load required for deformation. Load by cross-section area, from which you can be able to identify the stresses. That is the next level, stress calculations. We are going to study about the stresses in strength of materials. Then the relative motion in between the bodies, that we are going to study in kinematics of machines. Then we are going to study about the vibrations and balancing everything in dynamics of machines. So apart from that, we have designing of machine element, design of transmission systems, finally finite element analysis. This is the design group of subjects. So what is engineering mechanics? Let me see. So this is a kind of engineering science in which we are going to study about the bodies which are either at rest or in motion. If the study of bodies at rest, that is classified as statics. And another one, the study of bodies in motion, which is referred as dynamics. In dynamics, so the body which is at rest will start move only with the application of the force. Similarly, the moving body will come to rest only with the application of the force. So force is an agent which causes the motion or which makes the body to come to rest. Okay. So if the force required for the movement is not considered for the study, that particular domain of dynamics is referred as kinematics. If the force required for the movement is also considered in the problems, that is kinetics. Right? So with this introduction, let me start a particular topic in engineering mechanics called force system or system of forces. A system consists of several forces, different orientation of the forces or different nature of forces. So that is referred as force system. Okay. So basically this system of forces is classified as coplanar forces and non-coplanar forces. These coplanar forces are further classified as both coplanar and non-coplanar forces are further classified as concurrent and non-concurrent forces. What is meant by coplanar forces? If several forces are acting on the same plane, it is coplanar forces. Suppose if I have kept different amount of loads on a table on the same plane, that could be considered as a coplanar force. If you consider a solid, for example a cuboid or a square prism, it consists of how many surfaces? A square prism? 6 different surfaces, or cube, 6 different surfaces. In all the surfaces, different amount of forces are acting. So that kind of force system is referred as non-coplanar. If the forces are not acting in the same plane, if the forces are acting in the different planes, that is non-coplanar system. Then let us see about the concurrent force system. What is meant by concurrent? If the line of action of forces are intersecting at a single point, that is a concurrent force. Suppose 2 strings are used to hang the ceiling fan or a ceiling light. That particular system can be given as example for a concurrent force system, right? And then if it is a non-concurrent forces, if the forces, line of action of forces are not intersecting at a single point, it is non-concurrent force. Similarly, in the 3D systems also you can have. And then this concurrent, this coplanar forces can be further classified as if the forces are parallel to each other. Line of action of the forces are parallel. If they are parallel as well as their direction also identical means it is like parallel forces. If the direction of forces is different but they are parallel, that can be considered as unlike parallel forces, right? So this is a collinear force system. In coplanar force system, another kind also can be given. So if it is the collinear force system, it just refers the line of action of forces are in the same line, right? The line of action of forces for several forces are lying on the same line. It is collinear force system. The example sketch they have given, tug of war. The forces are acting in the same line of action, right? And then concurrent force system. So here I could say this as all the forces are in the same plane as well as collinear. So I could name this force system as coplanar collinear force system. This is concurrent force system. I could say this as coplanar, as all the forces are in the same plane as well as their line of actions are intersecting at a single point. It is coplanar concurrent force system. And here this is coplanar parallel force system. The respective examples you can refer the sketches. The concurrent force, you can see that sketch, you can understand that three forces. The forces acting on the string. The first string T1, tension is acting towards the ceiling, and then in another string T2 is acting towards the ceiling, and then the weight is hanging from the point O. So the weight is considered as one single force, T1 is another force, T2 is another force. These three forces are intersecting at a single point called O. That is why I can refer it as the example for concurrent force system. And then next to the parallel force system, it's a general kind, different orientation. They are not parallel. The forces are not parallel, but they are in the same plane. If it is so, if they are in the same plane, I can say it as coplanar non-parallel or non-coplanar non-concurrent forces. Likewise, according to the nature of the forces acting on the system, I could say the different names combined together. Starting from collinear force system, concurrent force system, coplanar force system, non-coplanar force system. Understand? Next slide. It is a concurrent. Okay, these are the same similar examples I have given. Again, now the method of approach to solve a concurrent and non-concurrent force system. So, what is the solution? What is to be solved in this type of problems? That is mainly the identification of the resultant forces in all the systems. In all the force system, how to identify the resultant force, that is the criteria. So what is meant by a resultant force? If several forces acting on a body are replaced by a single force with the same effect. If 5 forces are acting on the body and making the body to move for another 3 meters towards right hand side direction. If all several forces are replaced by a single force, and the single force also giving the same effect, which is caused by the several forces. If it is so, the single force which can able to replace all the forces is referred as resultant force, right? So in concurrent force system, if it is a not equilibrium condition, the resultant force can be find out by using this type of laws: parallelogram law, triangle law, polygon law, and method of projections. So this kind of laws of mechanics can be utilized to identify the resultant forces. What is this parallelogram law says? If two forces acting on the member are represented as two sides of the parallelogram, then its diagonal will represent the resultant of the two forces. Right? Generally, force is a vector quantity. So, while solving the problem or while finding out the resultant force, you need to find out both the magnitude as well as resultant. Then only it is a complete solution. Magnitude as well as the direction of the force, resultant force. That could be find out by using parallelogram law, where we could have the formula to calculate the magnitude of the load as well as direction of the load, resultant force. Then the triangle law, what does it say? if two forces acting on the member are represented as two sides of the triangle in order, then the closing side of the triangle will give you the resultant force in the opposite direction, right? And then polygon law, if more than two forces are acting on the member where we need to find out the resultant force, then polygon law is utilized. Here the forces, several forces acting on the member are represented on the sides of the polygon continuously. And then if it is so, the closing side of the polygon will give you the resultant force in the opposite direction. Okay, so these are all the methods to find out the resultant force. Okay, if it is an equilibrium condition, to find out the unknowns, what is meant by equilibrium in a 2D force system and 3D force system? The absence of forces causing disturbances. That condition is referred as equilibrium. If the forces are completely balanced, if it is a horizontal force system, the forces, right hand side forces are balanced by left hand side forces. And then if it is a vertical force system, upward forces and downward forces are completely balanced. That is, then the sum of the forces will be equal to 0. So equilibrium condition is sigma fx and sigma fy equal to 0 in case of 2D. The same thing you can have in case of a 3-dimensional structure. Apart from the forces equilibrium, we should have the moment equilibrium also. What is meant by a moment? What is the meaning of a moment? How will you find out the moment? It is the product of load into the perpendicular distance from the reference point. So the force will give you the linear effect, moment will give the rotational effect. If the forces are completely balanced, that is sufficient for a 2D force system. But there in the 3D force system, the forces has to be balanced. Similarly, the moment also has to be balanced. So apart from since it is a 3D system, we should say the equilibrium equations as sigma fx equal to 0, sigma fy 0, sigma fz 0. All the 3 dimensions need to be considered. Then the moment along the x-axis, moment along the y-axis, moment along the z-axis. So everything must be 0. Sigma mx equal to 0, sigma my equal to 0, sigma mz equal to 0. So that will be the complete equilibrium in case of 3-dimensional force system, right?